Good afternoon, everyone. Thank you for joining us. My name is Marissa Waterman, and I'm the Marketing Director here at the Academy. Today's webinar is titled South Pole Station Master Plan. Our Executive Director, Dr. Daniel Oather, will serve as the moderator and will introduce our speaker today. During the presentation, you'll be able to submit a question by clicking on the Q&A icon on the bottom of your screen. We will do our best to address each question at the end of the presentation. Before we get started, Dr. Oather would like to say a few words. Dan, how are you doing?
I am fantastic. Welcome to everyone, and thank you, Marissa. It's a pleasure to moderate today's webinar on the South Pole Station Master Plan. As we begin, I'd like to say a special thanks to Stanley for bringing us this webinar and for being a patron of the Academy. A couple of years ago, Stanley began its engagement with the Academy by sponsoring 4 webinars each year at a cost of $1,000 per webinar. The Academy's Webinars Committee worked with Stanley to vet proposed topics and speakers, and together, Stanley and the Academy brought some great webinars to our audience. Over time, Stanley recognized the value of Academy programs, not only our webinars, but our career networking fairs, our student chapters, our outreach to young professionals, including the 40 Under 40 recognition program, as well as the scholarships offered by the Environmental Engineering and Science Foundation, a sister organization of the Academy. All this to say, the engagement between the Academy and Stanley has been growing. A couple of years ago, the leadership at Stanley stepped up and made the commitment to financially support the Academy as a patron. And for $8,000 each year, Stanley continues to support the Academy. So do utilities and firms listed on this slide. And I thought I saw the sharing stop, and there it goes again, Randy. I appreciate it. The firms and utilities listed on this slide. Each utility provides $6,000 of annual financial support, and each firm provides $8,000 of annual financial support. These funds are essential to keeping our webinar series free to our members, from students to young professionals to seasoned professionals who hold board certification and participate in this program as part of continuing professional development. All this to say, if you want to sponsor an individual webinar, please reach out and let us know. If you'd like to join as a patron, please reach out and let us know. Marissa and I are here to listen to your story and help to match your needs with the Academy programming. And now, on with today's webinar. Today, it's my privilege to introduce Randy Duzan, who is the principal planner and landscape architect with Stanley Consultants. Since 1982, Randy has been delivering projects that involve master planning, project management, and design. Examples of the range of his projects include community development, military master planning, urban design, commercial and residential design, mobility planning, site planning, and entitlements. And today, Randy will be speaking with us about a really unique project, the South Pole Station Master Plan. As Randy delivers his presentation today, I remind you that I have the privilege of moderating a question and answer event at the end of the presentation. So it'd be great if you would share your questions in the QA panel, and I'll use those to direct today's discussion. And now with those instructions, Randy, my friend, the stage is yours. We're excited to hear from you. Those instructions, Randy, my friend, the stage is yours. We are excited to hear from you.
Thank you, Dan, for that introduction. I apologize for the internet. If it goes down, I'll just have to rejoin. There might be some need for a little bit of patience. Let's pretend we're at the South Pole and we're not getting our communication satellite working properly. But I hope this will be an interesting presentation. It is a very unique environment. And one of the uniquenesses is just the location and its environmental conditions that they have to work within. So yes, my name is Randy Duzan. I'm a AICP certified planner. I work for Stanley Consultants as a master planner, principal planner, and have worked on a variety of projects around the country and the world, from Saudi Arabia to the South Pole now. So hot climate, dry climate, to cold and dry. But just as a quick overview, I'm going to talk a little bit of the South Pole, past and present. Why did we do a master plan? And then briefly go through the process of developing the master plan. What were some of the challenges, and how we came to a plan, what was the information that we used to develop the plan. And then finally, I'll show you the results just in a plan. Obviously, I can't show you the whole document, but and there were several projects that were part of the master plan that came out of it. And then we have some renderings that we did for some 3D renderings to help illustrate the pole and the master plan. So this, and the other part about this presentation are some of the very interesting photographs that people who actually go and work there have taken over the years. So this being one, this is one of the primary telescopes that they have out there. And then the Royal Borealis, actually it's a Aurora Australis in the South Pole. The Borealis is in the North Pole. But we are, like I like to say, we're planting at the edge of the world, literally. This is the literal southern tip of the Earth. The geographic South Pole location is where this science facility is located. Their winter is basically March to October, where they have 24 hours of darkness, and their summer is October through March, where they have 24 hours of light. So it's a very unique environment. So let's imagine we're going to the South Pole. How do we get there? Well, you first, I don't know if you can see this camera thing. Here's a little map of how you get to the South Pole. It's not the only way, but it's one of the primary ways. Is you leave the U.S. and you fly to Christchurch, New Zealand. That is where the South Pole, the staging areas, the actual New York National Guard are the ones who do the flights. That is their LC-130 plane in the photograph. At Christchurch, they issue your gear, your winter gear, which are the red coats, and the bags have other gear in them, and you get the gloves and boots, and they're all required issue. You're allowed to bring a certain amount of weight of your own clothing and items, but they do have a limit. And so you arrive at the South Pole, you get out and you feel the coldness immediately. The time difference, if that's of any curiosity, it's basically New Zealand time, which is 18 hours ahead of mountain time, which is where I am. So it's roughly tomorrow afternoon there in terms of the time zone. So a little bit of history of the pole and the original discovery or trip was in 1912 by Amundsen and Scott, and they were the ones who first put a stretcher up, which is basically a tent you see on the right. And then in 1957, the Navy were the first group that began to occupy and do any type of research, and they did what is known as the Old Pole today. The Old Pole is now completely buried by snow, but it's set aside as a historical area as the original pole. In 58 they had the International Geophysical Year, and in 59 they formed the Antarctic Treaty that reserved the Antarctic for peace and science, and there were 12 signatories on that treaty. And then in 75, the first major structure was built, which is a geodetic dome. There's a picture of it on the right. It's partly buried in this photograph. And then in 82, the president signed a memorandum that appointed the National Science Foundation as stewards of the South Pole. And they continue to manage the South Pole today. And then in 1991, they needed to establish some guidelines on how to work at the South Pole. And so they established the Antarctic Specially Managed Area, the ASMA number 5, and the ASMA number 5 established zones and sectors. And you'll see that a little bit later, where different science is conducted with restrictions. So moving closer to today, the Antarctic Support Contract, ASC, are the ones who actually manage and operate on behalf of NSF. And they're actually the ones that we worked with in this contract to do the master plan, but we had a lot of involvement with NSF as well. But the ASC was the middleman. In 2008, they constructed the elevated station, the picture on the lower right. That is today basically the life support building where all the dormitories, cafeteria, gym, greenhouse, all the facilities are in this building, even today. And it's really the only place that they have living quarters. And beyond that, till today, they have constructed other buildings, other support buildings, which we'll get into in a bit, which are basically scattered around the South Pole. But in 2023, Stanley Consultants was contracted by ASC to develop the first ever master plan for the South Pole. To this date, a master plan was never done for the South Pole, which meant that there really wasn't an organized plan for how new buildings should be built and where they would be placed, or a plan to keep other areas cleaned up and organized. So this South Pole master plan has taken over 2 years to complete. And basically the plan is to create a vision for the next 30 to 50 years to modernize the infrastructure and operations so that science can continue to be supported. And so the master plan itself, the document, collected information in terms of what the current conditions are, which I'll get into, and then conducted a planning charrette to hear what the science community concerns were. And then out of that, a plan was developed and a list of projects, which we'll talk about later. So to talk a little bit about the master planning process, I like this slide or this image because it's a weather balloon that they put up every now and then. NOAA releases these balloons, but it was a time-lapse photograph that shows the process of a balloon ascending into the sky. And so we're going to talk about process. But first, what do they do at the South Pole is one of the questions that a lot of people ask. And these are the primary science disciplines that are at the South Pole, the atmospheric sciences, which is basically, not primarily, but basically NOAA conducts research there. The photograph in the top right is the Aero building, which is an atmospheric building facility that collects data on air quality. Astrophysics and cosmology are looking at the sky, basically the universe. The top picture, the ice cube, the MAPO on the lower right there, and the DSL are all science buildings that are in the astrophysics cosmology sector, which you'll see later. And they're basically telescopes that look into the universe and they try to look at the history of the universe, even as far back as the Big Bang. And then they also have some sensors in the eyes that collect sounds. And I'll say right now, I'm not a scientist. I'm a planner. But what I learned is these sensors in the ground collect neutrinos, which are coming from outer space, and they analyze them Geospace science and glaciology and seismology deal with the Earth core. They have sensors in the ice that actually can sense movement and vibration, such as earthquakes and other phenomena, which talk a little bit about that later. But then finally, they do medical research there, but primarily the medical research is on the people who are there. They want to know how living in tight quarters in a harsh environment, and even living at the South Pole over winter, what effects does that have on the body and on the mental condition and things like that. So the first part of a master plan is always understanding the challenges. So, why is it so hard there to operate, do science, to get there, things like that. One of the conditions that are contributing to all this is the Arctic conditions. I have a little note there that the mean average temperature is minus 56 degrees. The maximum can be a minus 117 Fahrenheit, whereas minimum -8, which is balmy at the South Pole. So the harsh temperatures are have an impact on buildings and support systems. But also along with that come snow drifting. There's a lot of snow drifting at the South Pole. You can see evidence of that in the lower right picture. These are arches that were built to support and house generators, fuel storage, vehicle maintenance shops, things like that. Well, the picture right above it is when the arch was built originally in 1990, and it was built on the surface of the ice. Well, today, over the years, the snow has buried these arches, and you can see the little bulldozer in front of one of them. Every year, they have to conduct snow removal operations to remove snow from the front of the building that has accumulated over winter. But it's a continual operation, and it's one of the reasons why one of the challenges is that these buildings are being crushed, basically. As snow forms over them, they exert a pressure on the void, which is the building, and they are due for replacement. And that was part of the big effort for the master plan. Some of the other challenges are travel logistics, just getting to the South Pole. I discussed earlier the route to get there, but one of the primary methods is the LC-130, and they are limited to a certain number of flights a season. They can't fly there in the winter. Basically, in the winter, it's locked down. You can't come or go to the South Pole because of the cold conditions and the weather and lack of sunlight, things like that. The other way to get to the South Pole is overland. You may have heard or be familiar with McMurdo Station. McMurdo Station is on the edge of the Antarctic continent, and that is also a NSF facility where they also do some research, but it's also where they offload cargo, which you can see the cargo ship on the bottom. That's where they offload cargo that's come from the U.S. And South Pole requires a lot of fuel per season. And so they put the fuel in these bladders that you see there, and they pull them by tractor overland. It takes about 3 weeks to get from McMurdo to the South Pole. So those are some of the challenges. The geodetic dome at the top there was an early construction. It has now been removed. It was removed and replaced with the arch structures. So moving forward, they want to look at, what are the next buildings going to be like? Some of the existing conditions, I already mentioned the blue buildings. The blue buildings are the science buildings. You can see them on the right there. Those are some of those buildings out in the cosmology area. And they're just called blue buildings because the material and the product that they use to build them are blue. So it's referred to as blue buildings. The elevated station, the upper right, is built on stilts so that it can be elevated as the snow accumulates underneath it. And it is actually behind schedule to be elevated. And so that was one of the big focuses of the master plan. You can see again the arches being buried on the top picture there. But also they have tunnels that connect these arches as well as other facilities. And these tunnels, which you see on the left there, over time, ice wants to close in the tunnel. And so they're constantly having to maintain these tunnels by shaving off ice on the walls, because the walls tend to, over time, bow in. And so they're constantly having to maintain them and keeping things open. So maintenance is a constant battle. The arches, they contain generators. You can see in the bottom picture there are 5 diesel generators that provide power to the entire South Pole, not only to the elevated station, but also to all sciences. The generators are what provide the power, keep the lights on, keep the buildings warm. You can see on the left bottom that they're putting cable in the ground, and they literally bury the cable directly into the ice. They trench it and they lay cable. But the ice, or the ice sheet that the South Pole facilities are sitting upon is 8,850 feet thick down to bedrock. And basically it is a glacier that is moving. And so the ice sheet moves generally in a southeast direction 10 meters a year. And so what happens is, and the ice sheet is not one solid piece, it has fissures in it. And so some segments of the ice might move a different direction. And so it puts a lot of stress on these cables that are buried. And so one of the big efforts that the South Pole recommended was doing a master utility plan to assess better ways of running cable, running wire and communications cable and water lines through the ice sheet. And again, nothing happens quickly at the South Pole, and so and nothing's cheap, and so it takes timing and years to get things done. So the master plan is designed to help look into the future, because a utility master plan has never been done. They just run the utilities where they need them when they need them. So, and then lastly, regarding existing conditions, the picture in the middle are storage berms, and that's where they put all their product that they need to work with, but it's also where they put materials that are considered retrograde or waste, because they may build a building or do something, and then they have this excess material that they don't need anymore, and they don't have the time or budget to remove it, to take it back out to McMurdo. And so just over the years has accumulated in these berms. And one of the things that was considered or recommended is that they begin the process of removing the retrograde, to help be good stewards of the South Pole, because environmental stewardship is a part of the treaty at the South Pole. So the existing layout of the South Pole, you can see in these plans here. On the right is the kind of macro view of what is represented by the Azimuth number 5 treaty. And I mentioned that they created sectors. And so this represents the sectors that were created. Dark sector is where they do all the cosmology, the telescopes, because it has less light pollution. The clean air sector on the bluer area is where they do, that NOAA does their air quality science. And you're not allowed to go into the sector. You're not allowed to walk in there, drive in there, do anything, because the instrumentation is so sensitive that it can sense the smells of material. We talked in our meetings, we talked about, well, why don't we put a new building out there? And they said, well, we got to be careful about whatever that building is made of, because the sensors can sense the aroma coming off of the material, the steel, the whatever it is, plastic. And so it's very sensitive. And then the pinker area, the quiet sector, that's where glaciology, seismology does their research. They have a sensor in the snow, in the ice, that is 8 kilometers away from the core area, to create separation, because it senses vibration. If you walk in this sector within a certain proximity to the sensors can pick up a footprint or a person walking. And so their sensors are very sensitive also. And so the master plan had to consider, how do we protect that zone? The downwind sector is basically the takeoff and landing pattern sector for the runway, or in this case, we call it a skiway, because they land on skids, not on, and they land on ice, not on asphalt. And then the next middle image shows you basically the core area. The dark sector on the upper left are the blue building locations. The arrow NOAA facility is number 23 there right in the corner of the blue area. But then on the right is a zoom in on the actual core area. This is where most of the buildings are. Life support building, elevated station, are the 2 buildings that look like horseshoes. And then the elongated buildings to the right of that elevated station are the arches, which are literally buried, but they're grouped together and they're close proximity to elevated station, because distance and time spent outside was a factor in where buildings were located. So they wanted to minimize time outside. And so they had a limit of a quarter mile for the maximum length of time to walk away from the core area. But you'll see that the new buildings were kept as close as possible to the elevated station. Interesting fact, how do they get their water? They do what are called rod wells. You'll see here the little circle in the lower right. They basically put a device in the snow, about 500 feet down, which is a heating element, and it creates basically melted water from the snow. It creates a bubble in the snow. And so that water accumulates, and then they pump it out from that well, and then pipe it over to a small treatment facility, and that becomes their water uses. They 650,000 gallons a year, roughly. That's a lot of water. And once a water well is exhausted, they drill another well. You can see other circles there for future wells. And then they use the abandoned water well for their sewer, and they pump sewer back down into the well. And that's how they store and get rid of their sewage, which basically over time, as they move, it'll freeze and they'll be there. And then I mentioned tunnels earlier. All these wells are connected by some tunnels. What you can see here is it's pretty cold down in the tunnels, but that's how they run their water pipes and their sewer lines through these tunnels. Wanted to give you a real life look at the South Pole layout. The aerial is most of the South Pole. What you don't see are the blue buildings off to the right side of the image. The map on the left is upside down because I wanted to orient it generally the way the aerial is. But you can see there the elevated building. The arches that are buried are immediately to the left of the elevated building station. And then you can see the various buildings, small buildings, outbuildings scattered throughout. And then there's an LC cargo plane taxiing into the runway. The bubble out in the distance is their communication satellite. There is an area north of the elevated station for tourists. Non-governmental agencies, NGOs, conduct trips to the South Pole. They are kept separate and away from the research station. And so they basically have to create their own camp. You see a photograph there of tents where they have to, where they sleep. There's an area designated for them, and it's right next to what is known as the ceremonial South Pole, which is the photograph in the middle there. It has a pole with a little bubble on it and the flags of all the nations that are represented at the South Pole. And that is where, when you go to the South Pole and you want a nice photograph to say that you were at the South Pole, this is where you take your photograph. But what some people don't know is that that's not really the actual geographic location of the South Pole. It used to be a few decades ago, but like I said, the South Pole, the sheet of ice is moving. Therefore, as the sheet of ice moves, the geographic point of the South Pole moves. Well, the ice moves over it, therefore it shifts in terms of where it's located on the ice. And I'll show you that in a bit. There is recreation. You got to keep busy, got to keep morale up. So within the elevated station, they have living quarters, a gymnasium, they have greenhouses, they have a library, they have a full kitchen. And in the summer months, even though it might be minus 30 degrees, that's relatively warm relative to when you're there. Your body tends to adjust to the conditions over time. So they play sports outside to get some exercise. So that was a quick little overview of understanding the place. So what do we do to figure out what they need? Well, the first thing we did, and it was basically a very key element, was we wanted to ask the science community what concerns they had and what recommendations they had. So we conducted a planning charrette to engage the science community, and there were basically anywhere from 22 different institutions, universities represented, but there were actually anywhere from 30 to 40 at any given time on the call. So the charrette was conducted around COVID, and so we had to do it virtually, which we probably would have done anyway because you can't really assemble that many different institution scientists in one place. But we used the platform called Mural, which is basically a whiteboard, a digital whiteboard. Some of you might be familiar with. There are other digital whiteboards out there. But not only did we include the scientific community, but because it was a federal project, we had to open it up to the general public on the call. And so at any given time in our different sessions, we had 4 days where we did charrettes that were 6 hours each. But they're anywhere from 100 to 120 on the call at any given time between scientists, the general public, and then the team, NSF, ASC, and Stanley on the call. And so it was a little bit of a management issue. So during this charrette, one of the things we really needed to do was give the science community an opportunity to provide input. And so we created a mural board, which is basically a board where you can put photographs, maps, schedules, whatever you want. You can basically digitally paste it on the board. And then anyone who's given permission, we only gave permission to the science community and some of the stakeholders. to actually put comments. But each day represented a different aspect of the charrette. And so we went through, talking about the structures, the facilities, the different science facilities. Each discipline had an opportunity to talk about their science projects and what concerns they had, what they needed in the future to conduct their science. And they put sticky notes on the board wherever they wanted to make comment. So it was a really slick way. And you could do this, the entire charrette participants could be putting sticky notes on there at the same time. So it was very interactive. So here's another example of day 3, actually, where we talked about specific science. And out of this, we basically produced some documents that listed what are some of the constraints of being at the South Pole, and the list at the top were some of the constraints that we kind of knew ahead of time, and then on the right, people added sticky notes about their concerns. And you can see, you may not be able to see it, it's kind of small, but budget was a big one. Money is always a big issue, especially when you're funding a lot of these large science projects. But the charrette was also recorded, so we had a transcript of all the days, which gave us an opportunity to go back and double check what was said. After the charrette, we began the process of collecting information that we needed from stakeholders, from ASC. Some of the reports have been done in the past, such as the survey of the South Pole on the lower right was done. And upper right was a document that the NGO provided to communicate to tours that went to the South Pole how you got to the location that was designated for the NGO camp, because arriving at the South Pole was very restricted in terms of what route you can take, because they don't want people randomly driving around, because all the science facilities are very sensitive in terms of equipment and in terms of electromagnetic interference, EMI. And so being too close to a particular facility could cause disruption in the readings of some of the instrumentation. So that's pretty well regimented. And then we had one of our team members, actually project manager from ASC, actually went to the South Pole. I actually did not go, unfortunately. And we needed to know, one of the big items that the South Pole Master Plan had to deal with is they didn't have nearly enough storage. And that's why they had a lot of these berms outside, because they're storing a lot of material outside that really should be indoors somewhere. And so they conducted an inventory of all the items, the amount of items that needed to be stored. And that provided us a square foot and a volume estimate of how much area and volume we needed in the future, which helped us size the new buildings so that they could actually bring a lot of this material into a covered facility. And then through the process of developing the various iterations of the plan, every plan was submitted for review by NSF and by ASC and by other stakeholders, and they provided review comments, which was put into a spreadsheet and reviewed, and each item was addressed throughout the process. So that was the process of collecting information. And so after we had all that information, we were able to begin to compile the actual master plan and documentation. Dan, I think at this time, just to give me a little bit of a break, if there's any questions about what I've said so far in terms of existing conditions and challenges, I'd be welcome to answer those.
Absolutely, absolutely, Randy. So we've got some great questions that are coming in. Some are very technical, some are very policy, some are more. So one that we'll ask you while we're in this space about the charrette and this process. So we think about Tuxman's stages of team development, right? The forming and the norming and the storming and all these sorts of things. So maybe if you might speak to a little bit, since you're talking about this charrette process and you're using Miro and you're bringing people together, how were you actually able to accomplish some of those kind of getting people to engage with each other and then engage with these virtual stickies? What did that actually look like in terms of this process?
I think one of the things that we did prior to the charrette is we sent out not necessarily some questions, but some objectives of what we wanted to learn from the scientists. And the charrettes were primarily for the scientists, the people who use the facility. And so they had time to prepare. We also asked them to prepare a brief overview of what they do, what kind of science they do. And so at different times during the charrette, we would say, okay, cosmology and basically the blue buildings that are the telescopes, the 10-meter telescope and the sensors. Tell us about what you do, what your concerns are, and do you have any recommendations? And of course, scientists love to tell you about their projects. And they had these PowerPoints prepared and they explained in great detail. And that's how I learned about the Big Bang project, because they presented the Big Bang and what they discovered, and they had graphics. It was really very interesting. But they also talked about, these telescopes and some other sensors require a tremendous amount of power. And so they had a need for additional power. And so that was one of the discussions that had to be dealt with because power is very limited. So yeah, we gave them an opportunity one by one, the cosmology and then the glaciology, seismology, all them, and then NOAA, they all gave their presentation and they documented it on the Miro board. And plus they sent us documentation separately so that we had that information.
Perfect. Thank you so much. Appreciate that, Randy.
Great. So moving on, wanted to touch a little bit on what types of engineering items that we had to investigate, what Stanley had to investigate. First and foremost, the structures were a big part of the master plan. We had to understand the dynamics of these arches. And we were asked to look at to suggest 3 different types of structures that could be used at the South Pole. And so using basically, existing knowledge, there is an elevated stage, a building already there. So the elevated building was one option for new buildings. A surface building was basically the arch built on the surface, and whether it was an arch or some other form had to be decided. And then finally, we did propose maybe bringing the dome structure back, because it does have a way of resisting the snowdrift because of the shape of the dome. But it has its limitations in that it is an arched ceiling, and it has a limited volume usage in terms of vertical storage and things like that. And so we ultimately ended up on the arches. So they're basically building back the arches, what they have already, but they're going to be bigger and larger because of that storage inventory we did. We realized how much space they really need to store basically their logistics building, to store all their material for life support, basically. And then the electrical component, we had an electrical engineer in our team from Stanley. One of the challenges was how are we going to replace the power generators And the whole idea of switching over from the old to the new. You can't lose power and you can't lose the warming of these buildings for very long. And so the whole procedure of building a new building and putting new generators in it, and then how quickly can you shut down the old and reconnect the new was a discussion. Mechanically, the mechanical engineers looked at the cabling and what could be done for future cables that had to be replaced. Is there new technology or are there new ways of connection points that don't stress when they're pulled because the ice moves in different directions? So that resulted in basically recommending a utility master plan. And then communications, the golf ball bubble out in the image you saw there is their satellite. And they transfer a tremendous amount of data because as science is collecting data, they want to get it back to their various universities, institutions to be analyzed and looked at. And so they're looking at new ways of improving communications. Starlink is one way of looking that they're looking at. But it's very important that they have basically the communications that is reliable and that it can transfer a tremendous amount of data at any given time. And then lastly, one of the big items we looked at is the airfield or the skiway. I mentioned the clean air sector. Well, the runway is oriented north, south in a kind of a westerly orientation. I mean, an easterly orientation. And so one of the issues they have, there's really two. One is on departure, the cargo planes take off, and there are times when the cargo planes, depending upon weather or weight or whatever, might fly over the clean air sector. Well, that's a no-no because the clean air sector science community says we don't want the air contaminated, and a LC-130 cargo plane flying into airspace is not good for their air quality. And so there was a consideration to maybe shift the skiway south so that there's a greater separation so that when the departure flight pattern, that there's more distance for it to turn away from the clean air sector before it gets over it. So that was looked at, but it was determined to not shift the airfield again. It costs a lot of money to shift an airfield or a skiway. So at this point, it was determined that the cost did not, the cost was too great for the benefit. So after analyzing and talking to the stakeholders and looking at what the primary projects were, there was a list of projects that were developed. The primary effort, the largest effort for the master plan was how are they going to replace the 5 primary buildings. And so you can see here, there are 3 concepts that looked at different orientations, and you can see we tried to keep them as close as possible to the existing arches because there still needs to be connection point either through tunnel or some method to the elevated station, which is the gray building in the top. And so we looked at these different orientations. Well, after there was another consultant that does all of the drift analysis studies for the South Pole to look at potential drifting, the accumulation of snow based on wind orientation. And so they looked at this and they basically recommended that they be oriented all in the same direction, which you'll see in a minute. And so the drifting model was a major determinant of how these buildings would be oriented. They're still in close proximity, but they were oriented in the optimum orientation. Of course, this is a master plan, so everything that the master plan recommends ultimately has to be tested, designed in the future when the projects are implemented, but it gives them a roadmap. One thing I'll point out here also is, if you can see, there are little circles and dash circles that are under these buildings. Those are abandoned wells. And one of the things that was suggested is that, can we put these arches on top of these wells? Well, these wells are 500 feet in the ice, and they're basically frozen over now. But the question was raised, are they structurally sound to support a building? Or are there other issues that need to be considered? Well, in the interim, it was determined that they would be structurally sound, and we could build on top of them. And because one of the items in the treaty is that we need to be environmentally sound stewards, the idea of building or reusing land that was used before, basically a brownfield in the ice, they like that idea of being able to reuse area and not necessarily put buildings in what I would call virgin areas or virgin snow that's never had anything on it. And so that was attractive to being good stewards. Lastly, I mentioned earlier about the pole, geographic pole moving. You can see on any one of these maps on the right edge of that green area, there are pole 2040, pole 2050, pole 2060. Those are the locations of the South Pole, the geographic point of the South Pole by that year period. So in 2040, the geographic South Pole will be down further south. The actual point doesn't move, but the ice is moving to it. And so everything moves with it. And one of the goals of the master plan, because this is a plan that looks to 50 years, is that they really would like to keep the primary facilities in close proximity to the geographic pole, just because it is a South Pole facility. They just want to keep it in relationship to the pole. And so you can see the box there says future station development. Well, ultimately, decades down the road, they're going to need to build a new elevated station, a new life support. And so this area was proposed as a site for that new building, which would put it in proximity to the pole location decades down the road. So those are the three concepts that were developed, and full documentation was provided along with this. In the final plan, it really ended up that most of the work or the recommendations of the poll focused or centered around the actual core area where the new buildings are. I apologize if you can't see the little buildings, the new ones proposed, but they're light tan and they're all parallel to each other. There were other projects that were recommended. Oh, here, I'm sorry, here's a picture in large picture. So you can see the different buildings are lined up. The first one is a power building where the generators are. The second two are the logistics buildings. That's where the storage would occur for all the products they need for the elevated station, supplies, things like that. And then the top right is the fuel facility where they have all the tanks for the fuel. And then the vehicle maintenance facility, the VMF facility, is for basically their maintenance shop for their vehicles, which are basically tractors and snowmobiles and things like that. So to bring it to a conclusion, the biggest part, or the part that NSF was really wanted to know about is how many projects and how much. Because the master plan will be the basis for seeking funding from Congress at some point. Of course, it'll be phased. Overall, as a result of the planning charrette, we compiled 82 recommendations. Out of the 82 recommendations, there were 29 projects identified for the future phases and 30 studies. There were a lot of studies that had to be done in order to gain more information to make decisions. So the master plan proposes a 4-phase process over the next 50 years. The first being mobilization. It'll take 5 years, plus or minus, just to get the material there, the equipment, the cranes, the actual structure. Most of these structures are erector sets. They make them in the States, they take them apart and they bring them on in pieces and they assemble them there. So it takes that long just to get everything there and to mobilize for a major construction project. And 5 buildings is a major construction effort. So the second phase is actually building these 5 buildings, as well as all the blue buildings and the elevated station are needing to be elevated. They're supposed to be elevated on a regular basis. They're kind of behind schedule, but they have to elevate them so that they don't get buried ultimately in the snow, which makes them unusable. And so all the major buildings have to be elevated, as well as building the new facilities. And then in phase 3, we're talking now probably 20 plus years out. Some of the support buildings would be constructed. Actually, I misspoke. Phase 3 is where these buildings will be raised. And then finally, at the end of phase 3, that would ultimately finish the primary projects. There were several smaller projects that really were not physical projects that you put on a map, such as buying a new radio system that doesn't produce EMI, that interferes with some of the instrumentation. But phase 4, the ultimate phase, is actually a maintenance phase where all these buildings have to be raised on a reoccurring rhythm, such as like every 10 years. And so there's always a rhythm of keeping these buildings up to date and elevated. So the ultimate master plan, which is being then produced, finishing this month. The purpose was to modernize infrastructure and operations to continue the scientific support of the South Pole Station. And wanted to show you some 3D imagery that we produced. This is the elevated station. This actually illustrates what it would look like after it's been elevated. So it has a greater distance underneath it. And then this picture actually illustrates the foreground is the cryogen building. That's where they elevate or inflate those weather balloons before they set them off. And then the arches on the right are the proposed new arches. The existing arches would be just to the right of the elevated station building, but they're completely buried by this point and basically just abandoned. This is an overview of the station. Not every single building's on here, just the primary buildings, but it does show the new arches to the right of the elevated station. The rendering illustrates only a few storage berms, with the assumption that in time, all the others that are retrograde have been removed. And then this is just a little closer view of that, of the core area. The blue buildings and the arch buildings in the foreground are called hypertats. They're actually dormitory living quarters for temporary workers. They only have a limited number of beds in the elevated station, and so when they do these construction projects, they have to place places for people to live temporarily while they're doing the construction. I want to thank you for allowing me to do this presentation. It's a very interesting project, and welcome any questions that you might have.
Oh, Randy, fantastic. That is so great. We really appreciate you. Thank you for being here for this. What I'm going to ask you to do maybe is we'll pull down the slides, and that way people will be able to see us kind of chatting a little bit. So if I can ask you to stop the screen share, we'll get back to this last one, but if you don't mind, and then that way people can kind of see us side by side. So great presentation. Got some questions. I'm going to kind of paint like a big picture, and then we'll come back and kind of pick them up a little bit at a time. So I'm kind of breaking these into some large areas. One that kind of talking about some policy. Who's got the jurisdiction there, right? You talked about NSF. There were a lot of government U.S. agencies mentioned, but international, so other countries. Got some specific questions. Folks were asking about the International Association of Arctic Tour Operators. So we'll get into some of that policies. The current administration budget cuts, with those part of this, and then got these ideas of these retrogrades, this removal of material from these burns. So who's really taking ownership of some of this sustainability? So that's kind of in a policy space kind of set of questions. Then we've got ones that are a little bit more in the technical space. So, if you're at the South, then what does it mean to talk about North? Everything's North when you're at the South. So how do you even do a map when you're thinking about?
You're exactly right.
You talked about time zones, and it's kind of like, well, if I want a different time, I just take 10 steps the other way, and I'm suddenly in a different. So, we wanted to understand some of that practical. It was interesting you brought up, I guess in my mind, and probably in the minds of a lot of people, we did not think about how big the Antarctic is. Folks were talking about it's Mexico plus the lower 48, all a huge area. Mile and a half high up, right? 8,000 feet, 9,000 feet above sea level elevation. So it's cold, but it's also way high up. So it's, higher than Denver. So those kind of working conditions, which then make us ask some technical questions, which, that glacier's shifted, right? So is that part of climate change, or is it just shifting, or is it the Earth's? So we want to try to understand. And does it all flow at the same, or if you go down 1,000 feet, is it kind of like these flows? So what does that matter in terms of drilling these holes and getting water and putting wastewater away? How, do they treat the wastewater before they inject it, or is this basically like, hey, we made this place where we got some drinking water and we just put it all back there. We don't worry about wasting power for treatment. We just dump it. There was the question which you feared would be there. What exactly are the total power needs? So we did get some engineering questions in there. So we'll see how you can handle some of those. And the idea, why not just switch to something like nuclear, right? Like, why drag these bladders of fossil fuel for 3 weeks' time? Don't we have nuclear technology that could work there? So, folks were asking some of those. Some questions that come in this kind of planning space, right? You talked about the constraints of this 1/4 mile outdoor exposure, but as the thing is moving, it feels like they're going to get further and further away. So, do you just simply build, 50 years from now, knowing that eventually the pole will move to where you want it to be? So, why not just jump ahead? This idea of the really sensitive instrumentation, that must have been really intriguing to think about. How do you go about in a planning space designed for that? Which also then brought to people like, well, what's the emergency procedures, right? You talked about the planes landing and taking off, and you don't want to mess up where your air quality instruments are, but accidents happen, like things go wrong with planes taking off and planes landing and that kind of stuff. So what are the emergency procedures for dealing with a facility that takes 3 weeks for somebody to show up and help them out? And then, one of the things we always like to conclude with is making sure we have some understanding of the future and the engagement, right? So we've got some students and emerging professionals that'll watch this. So how do they get engaged in these kinds of projects? What's the right kind of education to work in this space? Planners, engineers, scientists, all these kind of folks working together. So we'll wrap in that kind of words of wisdom. So let's bounce back up to the top of this list, this kind of like, policy, jurisdiction, right? So, all right, so who owns it or doesn't? Who creates the plan or not? Who makes sure it gets filed? I'm sure tongue in cheek, you're always like, well, do we, people don't follow the planner's plans anyway, but can you speak to some of those jurisdictional issues?
Well, the National Science Foundation operates the South Pole, and they fund it through congressional appropriation. And so it was one of the purposes of the plan was to help give them information to help plan and secure funding, which ultimately has to be approved. And of course, every project has an interest group. The cosmology guys, want money to put in a new telescope, but the seismology guys and gals want to replace their sensors, and so there's a whole undertone of working with all the interest groups. And that's not our job. That was the National Science Foundation's job to do. But this gave them a roadmap that they can work from. But the NSF controls it.
Okay, and so from a practical standpoint, we're talking about a U.S. government built and funded facility. And when we say international, it's really U.S. government playing nice and having other people come and visit. But it's not like, here's the Russian South Pole Station and the U.S. South Pole. It's essentially the NSF has the South Pole Station, and we play nice, and lots of folks come there. Is that a fair?
But it plays under the treaty agreement, a multi-nation treaty agreement. So other nations are participants, and I'll be honest, I don't know the ins and outs of the treaty and all that, but there are multiple nations that contribute to the effort. And I will say that it's not necessarily federal funding. I should clarify. Each individual science does also get their own grants to support their science. So the institutions can get private funding and other sources of funding to help implement their projects.
Makes sense. And of course, and you may or may not know this, but of course, it's kind of at the forefront of folks' minds about the, U.S. budget and what's going on. So I didn't know if you had any particular insight where was the South Pole. I quickly Googled to see anything about the South Pole with the current budget or the next budget. I didn't just, if your answer is I don't know, that's fine too. But have you heard anything about this project and where it stands? So
I don't know if there are any budget impacts, but I can say that the final edits of the document have occurred in the last couple months. And so we were given directive to remove certain words in the document that related to sustainability and resilience. We just reworded it and to just touch upon the nuclear and or alternative energy question. That was addressed because during the charrette there were a lot of questions about whether they can use solar or wind, even nuclear. But those are difficult questions. They're way above my knowledge level, but it's very difficult to do effective solar when you have zero sunlight for a majority of the time, and the winds are very sporadic. But you add to that, the vibration alone from the wind turbines can interfere with the science instrumentation and the EMI potential. And so it's a very complicated question. And so there wasn't a solution, but it was discussed that, we should always be looking at ways to reduce energy, because by reducing energy consumption, you reduce the consumption of fuel, which reduces the cost of bringing fuel. Everything boils back down to how can we save money so that more money can go to science.
That makes sense. Okay, so that was clearly part. So okay, so in that case then, and maybe if you can speak to this, so and this will be our last one kind of in this policy space. So this idea of this legacy of material that's there, and are we creating, kind of humanity's garbage dump at the South Pole, right? I'm thinking about folks climbing Mount Everest and thinking what base camp looks like there, right? So where was the appetite perhaps for making the site more sustainable or cleaning stuff up? Is it, is it in the priorities, or does it kind of depend on perhaps maybe administration, or does it depend on kind of the scientists there? They'd like to do the right thing, but they want to do that after they get their science done first. Or can you speak to how that fit? And I realize I'm putting you in a tough spot there, but if you can help us as environmental
Right.
engineers, scientists kind of understand where sustainability fit into the operation of the South Pole Station.
Yes, a good question. It is a high priority. There was a lot of discussion about how do we keep the station area clean. And when I talk about waste, I'm talking about old construction products, materials, vehicles that are no longer useful, not necessarily human waste. So there is a very specific project that was identified to remove as much of that retrograde as possible, because they do want to keep a clean station. And that, again, relates to whenever you remove something from the South Pole, whether overland or through the cargo planes, that takes up space for something else. And so they have to balance and prioritize what has to come and go and when. And that's one of the reasons why it's been a challenge, I believe. But they call it their backyard. They got to clean up their backyard. So it is a priority.
Fantastic. So a little bit now, maybe shift to some of the, a little bit more in the technical space, right? So if everything, if you're as far south as you can be, everything is north. So how do you manage this, what time zone it's in, or what is north, or that it's a mile and a half up? How did you orient to be able to do planning in a space that's so different than what we would have thought about from any of your other experiences with planning? How do you deal with that? Because I can imagine from the engineering standpoint what it would be like. How about from the planning standpoint? What are the tricks that you use to help orient to such a unique environment?
Yeah, it's an interesting question, but it never became a consideration. Our bearing was always the existing buildings and the sector map. If you remember the sector map, the dark sector, the clean air sector, so on. That was our orientation. Now there is an artificial grid that is placed on top of the South Pole, which has a X and Y geographic orientation. That is what they use. They don't use it off of the geographic pole. They have a point where I think it's one of the corners of the elevated station. So for engineering design purposes, they use this grid that's overlaid onto the South Pole plan where as their reference point. And so, 100 meters south of XY, whatever, is how they use to orient themselves. But us as planners really we didn't have to worry about north-south because all of our drawings were oriented north. Well, I take that back. You're right. Everything's north. So
it is.
So we artificially said, this is north.
Got it. Okay.
And we just went from there. Okay.
You picked a north, and that was good. I can
Yes.
just imagine it's got to be like that sign that you see, right? Like 1,000 miles to this and 1,000 miles to there. Right. So,
you're not the first person that brought that up. Someone else did just the other day, and I did before that. I never thought about it, but yeah, everything is north.
everything is north from that. Okay, and so then now
we didn't worry about time zones other than when we make phone calls.
Right, I would imagine that. Yeah, that probably does matter. So now we think about climate change, or we think about this, glacier and shifting. So, so is is the plan there where it says, okay, here's what it is in 2040 and here's what it is in 2060? Are they really confident in that? Does it shift at different levels? I mean, if you're going to drill down to get your water supply, I mean, is your old water supply and your new excrement pit running into each other at different levels? Can you give us any insight into how that is moving, if you had any of those details?
The timeline is not like any phase development in a master plan, nothing's set. It's a benchmark. But there are certain things that just absolutely have to happen within X time frame. They absolutely have to dig or drill a new water rod well now. And so they're actually in the process of developing the plans for that. And so that's a priority one project in the master plan. They absolutely have to begin the process of replacing these buildings because of their structural failure. And it's not going to happen tomorrow, but when you're talking about, doing a project at the South Pole, you're not talking about years, you're talking about multiple years. And so you have to start planning now, mobilize, so you know that in 5 years, you're actually doing it. It's kind of similar to a military project that, you do the planning for a military project, but it won't get built for 10, 20, 15 years. So it's long-term, a long-term horizon. But then there are projects that they want to get done, they want to get in the timeline, but not exactly sure when it'll happen because they got to figure out the funding.
Makes sense. So some of these things are more shovel ready than others, and to use that language, right? Like you
Yes.
got it. Makes sense. Makes sense. And so of course, being folks and environmental engineers and scientists, water is one of the things that's near and dear to our heart. Solid waste, air pollution, right? So is there a wastewater treatment, or do they basically just take everybody's sanitary waste? Stuff comes out of the sinks, it comes out of the toilets, and they just dump it back in another hole, and it just sits there and freezes? Or do they actually use some energy to treat it in some way before they put it back down? Or
I'll be honest and say that I honestly don't know the exact answer, but it was my understanding because we never really talked about it otherwise. And I think we would have talked about it if it were something in terms of needing a treatment facility, because we talked about what do you need? So it's my understanding that it is not treated, it just goes in the hole.
Sure. Or it's not one of their it's not one of the priorities, because if they didn't mention it, they probably don't need it. So
Yeah.
did you have any idea of kind of like total power needs? Do you have any numbers in that space? Or I know that you and I joked tongue in cheek ahead of time. Engineers will always ask that exact question about exactly how much power, exactly how much water, exactly how much fuel. Did you have one by any chance to answer that one? Or?
I know the exact amount because it's in the master plan, but I don't have it on top of my head.
No problem. No problem. So we can track that one down if we. So now
five diesel generators, and they only
five
use
diesel generators worth. That's.
But
I love
but
it.
they only use like 2 of them, then they have backups and all that.
Sure. No, that makes sense. That makes sense. So. Okay, so now one of the things that you talked about in the planning was this, these constraints that you had, right? Like they wanted to bring more stuff inside so that they can have it. Their instrumentation is very sensitive. They've got these, quarter-mile outdoor exposures and things. So when you were trying to put those in as a planner, did those loom larger than kind of some of the standard kind of, because you also talked about library and greenhouse and mental health, because you got some physical activity and sports indoor and out. So how do you as a planner balance some of the unique constraints that were in this site compared to the standard normal human constraints of having people in an environment, well, a little bit abnormal for 3 months without any other contact? I mean, maybe this is closer to a prison than any other design that you might run into, but how do you balance that as a planner?
Well, the focus of the master plan had to do with support facilities in terms of buildings. The master plan does not, in at least not in any detail, talk about the living conditions inside the elevated station in terms of do they want more light? Do the bedrooms need to be bigger or more windows, or, how do you deal with mental health issues? There is a section that is in the master plan that does touch upon those elements. It came from a prior study that was done, and so it was just added to this. But the main focus was outside the elevated station, because we consider the elevated station as a done deal. Nothing's going to change. You can't really modify it because it's contained. Now, that will be addressed when they decide to build a new elevated station. And they will consider whether they need, better lighting or better space for mental health and such as that. But we focus primarily on the science facilities and the support buildings such as the arches.
Makes sense. Makes sense. So then now when you got down the technical, you told us some structural, electrical, mechanical, communications, very clear kind of what things were there. One of the things that we had some folks asking the question on, of course, was emergency procedures, right? So how does dealing with worst case scenarios in a place that's so isolated, how does that factor into a master plan?
There is a medical team at the South Pole. They have a surgical room for procedures if they need it. They have vehicles for rescue if they need to, because not only do they conduct science at the South Pole, they also conduct what is known as field science. So they have excursions out into the Antarctic tundra, that if they need to rescue that person because of injury or weather conditions or whatever, they have a team there that conducts that operation. If the weather's good, they can potentially use overland track vehicles that can go out into the snow. I don't believe that they have any small aircraft that goes out. There was never a discussion of helicopters. But in terms of evacuation, of course, in the summer, they could, if the weather's right, send an airplane to the pole if the emergency was a high priority. If they can treat it there at the station, then they'll do that. But we didn't really, again, get into, we talked about what the medical team needs in terms of maybe some additional space in storage area. But we did not really get into any change or discussion of evacuation.
Okay. Great. No, appreciate that. There are a couple of specific questions you might have the answer to. We know somebody noticed on one of the drawings, WRW, and the interpretation folks thought was that, does that stand for the waste recycling well by chance? It was looking at one of the plan, one of the schematics. So does that sound right?
WRW, it was probably the waste
Recycling.
well.
Okay.
Waste. Yeah, or it could just be an acronym that was like an identifier. I apologize for not knowing exactly.
No, it's not a problem. That's where I said I just ask a couple of these just in case we have an answer. One question was relative to the snow, right? Could you build stuff up, or a lot of pictures we're talking about kind of trimming it or pulling it down. Can you also essentially, can you use snow as a building material? Can you build stuff up and then use the snow? I mean, is that, and I realize that kind of gets into maybe more the engineering details about structural load and moving it and all, but in the general space you're in, did you think about also moving, as opposed to just excavating snow or ice? Do you also think about building on it or using it as part of the building materials?
Absolutely. That was actually a very important discussion during determining what the best structure would be to replace these buildings. And although they settled upon just building the arches, but building them bigger, they want to build them on top of a snowpack that they would create a snowpack or platform that is 20 feet high and then build the arches on top of that. So that would lengthen the period of time and create a longer lifespan for these arches from being buried by the snowdrift
Okay.
by elevating them. Because if they're up elevated, then the snow has to go up and
Yeah.
they can push it down. And yeah, that is absolutely one thing that they're considering.
Okay. And so that then these burying was actually, it's a lot of drifting actually that's across the surface. So if you get up a little bit above it,
It's all drifting.
it's all drifting. Okay. So
The
it's not
drifting,
fall, it's drifting snow. Okay.
the
Okay.
drifting snow is what buries everything.
Okay, makes sense. Makes sense. All right. So that takes care of a lot. Like I said, I had a couple of like specific ones. One that I had mentioned earlier. Don't know if you had any familiarity with it, but the International Association for an Antarctic Tour Operation, was that part of this particular one that you ran into? Discussion of folks, because you had mentioned these kind of buildings and tourists, but I thought maybe you were saying that as opposed to like, hey, I can pay my money and go visit the Antarctic station. This was more, visitors brought in for other purposes that people brought in for the photo op because hey, that's how we raise money for the place or something like that. So
the NGO tours have nothing to do with the station itself.
Got it. Okay.
But they have to be good neighbors.
Okay.
And so there are agreements on where they can be, how they get there, what routes they can take to get to their camp. Some fly in, some of them come overland.
Okay.
But they set up their own camp with their tents, and they're not permitted to walk into the station operations area.
Okay. Fair enough.
They're separate operations, and we mentioned them in the master plan because they're there, but we didn't really talk about other than maintaining their separation.
Okay. Sounds good. So last kind of space, we've got young professionals, we've got students, we got folks looking for second, third career. We've got people that are always interested in collaborating. And so, how do folks, you're coming from a planning background, obviously very familiar working with engineers and scientists. This was a fantastic example of very, very multidisciplinary project in a really challenging space. So words of wisdom for folks that are trying to work in this space, things they should be studying, things they should be doing as emerging professionals. What advice would you have for people?
So good question. Well, I am actually a registered landscape architect, if you can believe that. There are no trees at the South Pole.
No rain garden.
No rain gardens, anything. But the majority of my career is I'm a AICP planner. So if you're interested in planning, getting a master's in planning, or regional planning, or there's several universities that offer that. But as far as getting into kind of science related, I would look at the National Science Foundation website. They have an extensive page devoted to the South Pole. And not that you would anybody would find anything on that site to get them into the South Pole work, but there are numerous organizations that participate in the South Pole. And so you name the science, and there's probably some organization that has some contact with the South Pole. And so you can kind of pick and choose and look around. But I'm doing the South Pole project. It's a project that I never thought I would do in my life. Who does? And so just happened to work for the right firm that proposed and won the project. But we also put together a good team. We have a good multidisciplinary firm that I think was attractive because it needed a multidisciplinary approach.
Good. Well, Randy, thank you so much. We really appreciate this presentation today. It was fantastic. I know Marissa will ask us if we put that last slide back up again because it's got some details, if that's not too much headache for you, but we really appreciate you. We appreciate Stanley being a patron, and thank you for a fantastic webinar today, Randy. Thank you very much. Marissa, over to you.
Thank you.
Okay, thank you everyone for all your questions, and thank you to Randy for sharing your knowledge with us today. We have several webinars planned in the near future, so you can go to aaees.org/events and reserve your spot. Just a reminder, if you're not yet a member and you're considering joining the Academy, you can email me and we can discuss membership options. For all board certified individuals, PDH certificates for this event will be sent out by the end of the week. That's all for now. We enjoyed being with you all today. Thank you so much and have a great day.
Thank you.